Hello everyone. This is the final lesson of the spherical storage tank. So we're almost done. Last lesson we made this staircase over here, and there's a problem with it, which is these parts, which is basically just inside the stair. So we can fix that by changing a bit of our code over here. First though, we have to change some stuff. So I made this drawing, and basically it shows this is the spherical stake, this is the first step, this is the final step, right? Previously our stair revolution was 1.75, but this time I'm going to create a new variable called stair revolution on tank, which is basically the stair revolution. However, we're just gonna pretend like each of these steps are like straight are on the tank, straight to the left or the right. So this is 1, 2, 3, 4, 5, and so on. And when we finish that, the revolution would not be 1.75 pi. It's going to be just math.pi, which is 1 times math.pi, which is 180 degrees. So stair on tank revolution equals math.pi. Okay, and now over here, let's draw the problematic steps. Over here, it's kind of like this because the inside is like over there, and basically we want the x-coordinate to be wider. It's not the best x-coordinate, but I think it works. Now you need to move the x-coordinate like out of the tank, right? Right. Okay. So I'm gonna show you to do that, but it's not gonna make sense at first, but I'll explain. So now we have I, right? We have t equals I divided by the number of steps. So I over something, depending on how large the I is. And we have angle I, which is the stair revolution times t. Basically, the angle. Right. Then z I is just the z coordinate of the I. So if we go back here, this is going to be the smallest number, this is going to be the biggest number, 0 and 1. We're going to change things up a bit. So with the new stair revolution, we have let's talk about this first. Our angle to be like I don't know how to um wait. Okay, so it's not that good, but the angle's kind of like that. The first part here, the angle's not going to be really big, and then it slowly gets bigger as you move along. Like here, it's going to be bigger, bigger, bigger. But when you get here, the angle's going to be a full circle on pi. A full circle. Whereas over here, it's not going to be a full circle angle. Now let's code the angle thing in here. So now we can over here. Where is it? Here. Um. Oops. So the interpolation for step center radius are center and step along tank angle equals stare on tank evolution times t. Okay, so now that we have defined that angle, we still need to do something. So this is the y coordinate, right? And okay, we have the x coordinate here, the y coordinate, and oh, that's not the y coordinate, that's the radius. How do I edit? Okay, so I guess I messed that up. X coordinate. My line disappeared. Radius. Yeah, I just spelled that wrong, but you know what that says. So, you know, this angle, right? This is the step along tank angle. Okay, but what about this one? This is the other angle. And this is the other angle. So how do we find this other angle? Well, also we need this other angle so we can find the y coordinate. This other angle is just f.pi, so this minus step along tank angle, which is this. So let's code that. The the other angle equals math dot pi minus step along tank angle. Okay, so now I have this angle. I can find what this is. Never mind, it's not this. We want to find this. Which is also this. And so we know this angle and this place. I could find this. Right? Yeah, we're finding the x coordinate. Which this and yeah. Okay, so how do we do that? Well, we've already done this many times in our previous lessons, but we use math.sine this angle, and then we multiply that by the sphere radius to get this. Okay, so x coordinate equals math.sine other angle times sphere radius. And why sphere radius? Well, because that's just this. That's sphere radius. Okay. Okay. Now we can shift this out because we know half the stuff is inside. We can create a gap to move it out. So let's go up here. Gap to keep steps clearly outside the tank. Let's make the gap the 1.2, no 0.2 of the sphere radius. Now we create the gap. Let's go back here where it says R center where is it? X coordinate. Okay, here R center equals max R center R interp R sphere plus half of the step width so that it can go out, but then we can add a gap because if even if half we make it go out a bit, it's still a bit of it is still gonna get in. Okay, now if we run this, tank angle, not tank angle. R sphere is not defined. Oh wait, they said that wrong. X coordinate. Okay, now you can see that everything is outside of the tank, and it's Looks good, right? If you think the gap is too big, you can change the gap a bit. This is good, but like it's barely good. So you can do what you want to fiddle with it to make it look however you want. But that's it for today's lesson. Bye.